Welcome to the Deep Dive, where we cut through the noise and get straight to the strategic heart of the matter. In today's world, things are so volatile, so interconnected. Trying to plan with a static roadmap, it just isn't cutting it anymore. Strategy isn't really about those rigid plans we used to make. It's more about understanding how everything connects, how one decision can ripple outwards, how constant change shapes your entire landscape. And that's why systems thinking, it's not just some, academic buzzword. It feels like a practical necessity for anyone trying to navigate all this complexity. Our mission today really is to explore exactly how systems thinking can completely transform those traditional strategic approaches, how it offers you maybe a shortcut to seeing the patterns, not just the isolated parts. We're talking about shifting your whole strategic worldview.
Absolutely. And we're going to try and fundamentally reframe some core strategic concepts, things you might already be familiar with, and show how using a systems lens can give leaders, well, incredible foresight and precision. We'll take you on a bit of a journey from understanding the mindset to how you can actually model these systems practically. And finally, we'll touch on the critical responsibilities that come with using such powerful tools. Because really, the core idea for this deep dive is simple. If you only see the parts, you genuinely miss the strategy.
Okay, so let's unpack this a bit. For decades, strategic thinking has been very linear, right? Identify a problem, find a solution, move on. But in this fast-paced, data-rich world we're in now, that just isn't enough. Like you said, every decision creates these complex ripple effects. So from your perspective, why exactly are those traditional linear approaches falling short today?
Well, the fundamental issue, I think, is that traditional models often risk oversimplifying reality. Strategic challenges today, they rarely stem from just one single isolated source. They emerge from these dynamic interactions, constantly shifting customer preferences, industries converging, regulatory changes popping up, and especially these digital feedback loops that can amplify even tiny moves into system-wide effects. Systems thinking fundamentally shifts the strategist's lens. So instead of just seeing the isolated parts, you start to see the overarching patterns. You move from focusing on single events to understanding the underlying structures that produce those events. And from just, reacting to symptoms to truly addressing their root causes, it's a complete paradigm shift, really.
That's a powerful way to put it, a paradigm shift. So if we embrace this new lens, how do we start to reimagine these core strategic concepts we thought we knew? Let's start with a classic, Porter's value chain. Traditionally, it's that sequential flow, isn't it? Procurement, production, distribution, marketing, service. Optimize each step.
Exactly, that's the linear view. But in systems thinking, that flow truly transforms into a dynamic feedback loop. Think about Zara, the fashion retailer. In a conventional value chain, their retail stores would be kind of the end of the line. But for Zara, the real-time data from those stores, what's selling, what's not, what customers are asking for, that's the absolute starting point of their cycle. Store managers are feeding back purchasing trends, customer comments, back to designers and manufacturers, like daily. This incredible data-driven feedback loop lets them compress their design-to-shelf cycle down to, sometimes just 2 weeks. Their competitive advantage isn't about optimizing one single activity. It's about how rapidly and intelligently their entire system adapts and responds to the market signals.
Wow. So Zara's edge isn't just fast fashion. It's really a fast learning system. It's adapting constantly to real-time signals. That is a huge shift from the old value chain idea. Okay, let's pivot then. What about strategic fit? Traditionally, that meant finding that static alignment, right? Matching your internal capabilities with external opportunities. And once you found it, you just sort of sustained it. How does that hold up now?
It doesn't, really, not in that static sense. In a world of constant change, especially digital disruption, fit isn't some fixed state you achieve and hold on to. It's continuously shifting. Systems thinking reframes fit as more of a dynamic equilibrium. It's an ongoing, active balancing act between a firm's evolving capabilities and its constantly changing environment. Netflix is a perfect case study here. Their first strategic fit, mail-order DVDs. Then they saw the systemic shift coming towards streaming. They adapted. Today, their fit is all about matching hyper-personalized content creation with global viewing patterns, something only possible because of AI and real-time behavioral analytics. Each phase involves sensing these big systemic shifts, rapidly reconfiguring how they worked internally, and constantly testing new models. It's more like an adaptive dance than a fixed position.
Adaptive dance, I like that. Not a fixed formula. And what about organizational alignment? Historically, that brings to mind rigid structures, top-down control, making sure incentives and reporting lines all match up in a static way.
Right, the old hierarchy chart. But in a systems-enabled firm, alignment moves beyond that rigidity. It becomes more like synchronization. Take Ping An, the Chinese financial services giant. They manage this vast platform, insurance, healthcare, fintech, not through rigid command and control. Instead, they build shared data systems, synchronize APIs, feedback-rich dashboards. This allows each business unit to adjust locally but stay aligned with the global strategy. Ping An became one of the world's most valuable financial platforms, not by just scaling linearly, but by evolving systematically. So alignment through the systems lens is really an outcome of continuous dynamic coordination across all these interdependent parts. It's not just something you design once from the top.
That's a powerful contrast. Okay, so we've seen how systems thinking can radically reframe our understanding of strategy itself. But for someone maybe just hearing this term clearly for the first time, how would you define it? What is systems thinking in a nutshell?
In a nutshell, okay. At its core, systems thinking means going beyond simple cause and effect. It means viewing organizations, industries, markets, whatever, as dynamic systems, as complex networks of interdependent elements where the structure, how those elements are connected, actually drives the behavior you see. Linear thinking, on the other hand, it typically just sees if X happens, then Y follows, which works fine for simple, predictable things, but it completely falls apart when you're dealing with the complex strategic challenges we face today.
That's a crucial distinction. Let's maybe take a common scenario, like a drop in employee productivity. A linear view might jump straight to blaming individuals, maybe saying they need more training. But a systems view, recognizing that interconnectedness, would dig deeper. It would ask, is this dip linked to rising project overload for a specific team? Is high turnover creating a feedback loop of knowledge loss and rework, putting more strain on everyone left? Are the incentives maybe misaligned? Are they unintentionally encouraging the wrong behaviors? A systems thinker knows that today's quick fix in one area can easily become tomorrow's big problem somewhere else if you don't understand that underlying structure.
Exactly, and that's where the core differences between linear and systems thinking really stand out. Let's break it down. Causality. Linear thinks one cause, one effect. Systems. Multiple causes, circular feedback loops. Much more complex, focus. Linear isolates problems. Systems looks at interconnections across the whole system. Response. Linear is often reactive, just fixing symptoms. Systems thinking aims to be proactive, to address the root structure, how you use data. Linear might just track KPIs. Systems thinking looks for patterns, loops, flows within that data. Your mental model itself changes, from thinking in straight lines to thinking in loops, webs, and understanding the impact of time delays, which are huge. And finally, strategic risk. With linear thinking, the risk is oversimplification, which is dangerous. With systems thinking, the challenge is managing complexity, but you have a deeper awareness.
The Amazon Prime example you brought up earlier is probably one of the best ways to see this in action. It's clearly not just a loyalty program, is it? It feels more like this self-reinforcing engine. Growth, cost advantage, customer lock-in, all driven by these interlocking feedback loops.
Absolutely. It's a brilliant example. Think about it. More Prime users means shipping costs drop because of scale, faster, cheaper delivery. That boosts customer satisfaction. Happy customers spend more, engage more on the platform. Higher sales then fund more warehouses, better logistics tech, which further improves delivery, adds more value to Prime. These loops just constantly reinforce each other. That makes Prime incredibly sticky and gives Amazon this dominant position. You simply cannot see that kind of dynamic compounding power if you're only looking through a linear lens.
It's fascinating. And it strikes me how deeply systems thinking is rooted in these STEM foundations. Science, technology, engineering, math. It feels like these disciplines are just naturally equipped to handle this kind of complexity. Can you elaborate on that connection?
They absolutely are. They provide the toolkit. First, you have scientific logic. This is the bedrock of causal reasoning. It's about forming hypotheses, testing them experimentally, validating your models with data. Think of Google's Project Oxygen. They didn't just collect data on managers. They spent years analyzing it, forming hypotheses about what makes managers effective, testing those, and continuously refining their understanding. It's that rigorous, iterative process. Then there's technology and simulation. This is what makes these complex systems visible, tangible. Digital twins, virtual models of real things like a warehouse layout or maybe hospital patient flow let you test ideas without messing with the real world. Huge savings in time and cost. System dynamics tools like VenSim or Stella, they let you actually build and play with these complex feedback systems. I know a national retail chain used system dynamics to figure out how promotions would affect not just immediate sales, but also long-term store traffic and even brand perception. Much smarter pricing came out of that. And agent-based modeling lets you simulate individual behaviors like customers or employees and see how collective patterns emerge from those interactions.
So the tech really lets you see it and test it. What about engineering?
Right, engineering design brings in concepts like designing for resilience, for control, often using feedback loops. Engineers design self-correcting systems all the time. A famous tech example is Netflix's Chaos Monkey. It's software that intentionally disrupts their own services in the cloud just to test how resilient the system is. That mindset translates strategically into preparing for failure, not just planning for success. Building in redundancy, designing for rapid recovery.
That makes sense. And math and stats.
And finally, yes, mathematics and statistics. They provide the precise tools to model these often nonlinear dynamics. Bayesian inference, for instance, lets strategists continuously update their beliefs and models as new data comes in, absolutely crucial when things change fast. Regression, time series analysis help forecast trends within the system. And network analysis, you see fintech startups using this a lot, helps map how things like user referrals or influence spread through complex networks, letting them redesign for better growth.
That's incredibly comprehensive. And Ping An, the company we talked about earlier, they really seem to embody this integrated STEM strategy, don't they?
They really do. It's a fantastic example. They apply scientific logic in their Ping An Good Doctor Health platform, constantly testing hypotheses about AI diagnostics combined with telemedicine. Their smart city projects use digital twins and sophisticated tech for real-time modeling of urban systems. They used engineering principles to build modular business units independent but connected through shared data infrastructure that gives them resilience. And mathematically, their AI engines use advanced techniques like Bayesian inference, machine learning for everything from insurance underwriting to fraud detection. They truly transform themselves into this coordinated adaptive system by leveraging all these STEM foundations.
Okay, now here's something I think trips people up sometimes. Analytical thinking and systems thinking, they can sound similar on the surface, but they're fundamentally different approaches, aren't they? Analytical thinking is all about breaking problems down, right, into smaller, manageable parts. Systems thinking is about understanding how those parts interact and influence each other as a whole.
That's the crucial distinction, yes. Analytical thinking has really been the dominant logic in business for decades. Its core traits: linear causality, breaking problems down, decomposition, aiming for optimization or control, often with a short-term snapshot view. Its strength is clarity, precision, efficiency, especially when the environment is pretty stable. A logistics firm might use it to optimize delivery routes, maybe cut costs by 12%. Sounds great, but the limitation is huge. Optimizing the parts doesn't necessarily optimize the whole system. In fact, it can make the whole system worse. Slashing supplier costs might look good analytically on one spreadsheet, but if it leads to delivery delays downstream, erodes customer satisfaction, damages your brand trust system-wide, that optimization was actually destructive. Analytical thinking often misses those indirect effects and feedback loops.
Right. It optimizes the silo, potentially at the expense of the whole. And then when we pivot to systems thinking, the core traits are just completely different. You're looking at nonlinear causality, focusing intensely on feedback loops and those tricky time delays. It's about pattern recognition, what's recurring, what's accelerating, what's slowing down, and always keeping holism and context in mind. The goal is to look beyond those surface symptoms, like the productivity dip we mentioned, to uncover the underlying structure driving the behavior. The challenge, I guess, is that it can feel a bit messy, maybe overwhelming, requires comfort with ambiguity.
It absolutely can. It asks you to hold more complexity in your head. Consider Boeing's 787 Dreamliner outsourcing decision. Analytically, on paper, it looked fantastic, a clear path to cost reduction by outsourcing major components. But systemically, it led to this profound loss of integration, loss of control over the supply chain. That caused cascading delays, serious quality issues, huge cost overruns, and really damaged customer relationships. A systems thinker, looking at that up front, would have tried to map out the feedback loops. How does coordination complexity interact with supplier knowledge gaps? How do timeline delays in one part amplify delays elsewhere? They might have seen that a more integrated production ecosystem was needed from the start, even if it looked less optimal analytically in the short term.
So the big takeaway here for strategists, it seems, isn't about choosing one or the other. It's about synthesizing both, right? Analytical thinking helps us measure the pieces, optimize them where appropriate. But systems thinking shows us what truly matters in the bigger picture, how everything connects. Together, they enable not just efficiency, but genuine, sustained evolution and resilience.
Exactly. That integration creates a real strategic sweet spot. And we can actually break this down into a practical sort of 4-step process for bringing them together. First, always frame the system first. Start with that systems view to make sure you're not solving the wrong problem entirely. That transportation firm seeing delivery delays. If they start with systems thinking, they might realize rerouting trucks is pointless because the real bottleneck is in the warehouse loading process. Framing first prevents treating symptoms. Second, once you understand the system structure, use analytics to target leverage points. Now bring in your analytical tools. Quantify the impacts of different factors. Prioritize where you intervene for the biggest effect. For instance, map the emissions hotspots in your supply chain using systems thinking. Then use analytical models like ROI calculations to compare investing in solar retrofits versus a full supply chain redesign. Analytics sharpens the focus.
Okay, so frame the system, then use analytics to find where to push. What's next?
Third, design feedback-aware interventions. This is key. Avoid those one-off fixes that often backfire. Design your actions so they inherently reinforce positive loops or dampen harmful ones. So instead of just giving bonuses for short-term sales bumps, maybe link bonuses to customer retention rates. That creates a reinforcing loop. Better service leads to loyalty, which leads to sustained revenue, which funds better service. You're building self-correction into the strategy. And fourth, monitor, learn, and adapt continuously. This isn't a one-time exercise. You need to blend analytical dashboards, your KPIs, with ongoing systems diagnostics. Are the loops behaving as expected? Are there unintended consequences emerging? Smart cities are a great example here. They use both traditional performance indicators and complex digital twins to simulate and adapt strategies for things like traffic flow or energy use in real time, ideally before a crisis hits. It's a continuous learning cycle.
Unilever's waste reduction strategy sounds like a really powerful example of putting this integration into practice. You mentioned their analytical approach helped pinpoint high-impact waste categories, like single-use plastic sachets. They could calculate costs and benefits of different materials. But the systemic insight was realizing that even biodegradable materials wouldn't solve the problem if they just ended up in landfills anyway, because the underlying consumption system hadn't changed.
Precisely. So they shifted. They started mapping the causal loops, connecting affordability, consumer habits, waste infrastructure, policy, the whole web. And instead of just switching materials, they started partnering with local governments, NGOs, to co-develop reuse models. They piloted digital incentive systems to encourage recycling. They were effectively redesigning the entire consumption system around sustainability, not just tweaking one component. They saw the whole picture.
That's a fundamental shift.
And if you want the ultimate example today of this kind of integrated thinking, you probably have to look at Tesla. They demonstrate incredible analytical precision, predictive maintenance on cars using sensor data, super accurate battery performance modeling using complex math. That's the analytical side. But their real genius is the systems thinking. They see their business not just as making cars, but as building an interconnected energy system. They actively create reinforcing loops. More EVs drive down battery costs, which makes solar storage more viable, which further supports EVs. They build this whole ecosystem architecture where their cars, batteries, solar panels, software all feed data and value into each other. And they're constantly thinking systemically about policy shifts, charging infrastructure delays, grid impacts, anticipating the evolution of the entire energy landscape. It's the seamless blend of analytical rigor on the parts and profound systems thinking about how the whole thing fits together and evolves. That's what lets them master the details and continually reimagine the whole game.
Okay, so if systems thinking provides the mindset, the why, and the what, then modeling is really the how. It's how these abstract insights become tangible, how complexity becomes, well, maybe not simple, but visible. And crucially, it's how our big strategic decisions can be tested before we commit huge resources in the real world. It helps us explore the what could be.
Exactly. A strategic system model is essentially a visual and conceptual map of how the key elements in your strategic world, customers, competitors, resources, capabilities, regulations, how they all interact, evolve, and influence each other over time. It answers the fundamental questions. How does the system actually work? And what is likely to happen if we intervene here or here? It lets strategists see the hidden structure behind the day-to-day events, identify those non-obvious leverage points we talked about, and anticipate unintended consequences before they bite you.
And to build these models, we need to understand the basic building blocks. Let's maybe use an example like customer lifetime value, CLV, for a subscription business. What are the pieces? You've got stocks, right? These are accumulations, like your total number of active subscribers at any point in time.
Correct. Stocks represent accumulations.
Then flows are the rates that change those stocks, like the number of new signups per month flowing in or the churn rate flowing out.
Exactly. Flows are rates of change.
And feedback loops are those crucial circular cause and effect chains, like Maybe happy customers refer their friends, which increases new signups, which leads to more happy customers. A reinforcing loop.
Yes, reinforcing or balancing loops. They drive the dynamics.
We also have delays, which are super important. The time lags between cause and effect, like maybe a new training program impacts employee performance, but only after 6 months, not instantly.
Delays are critical and often underestimated.
Then you define the boundaries. What's in the model, what's out. And non-linearities, where small changes can cause disproportionately large effects, like hitting a tipping point in market adoption.
Precisely. Those are the fundamental components you use to represent the structure of the system.
And these blocks are used to build different kinds of models.
Right. There are several types. Causal loop diagrams, CLDs, are great for visualizing the feedback structure quickly. They map out those loops qualitatively, like showing how R&D investment might lead to better products, which attracts more customers, generating revenue, allowing more R&D, that classic growth loop. Stock and flow models are more quantitative. They track the actual quantities in the stocks over time, driven by the flows. Really useful for detailed things like workforce planning, hiring, attrition, skill levels, or modeling inventory turnover dynamics. You can simulate these over time. Then you have system archetypes. These are like templates for recurring patterns of problematic behavior in systems. Fixes that fail is a common one, where a short-term solution makes the underlying problem worse later. Or shifting the burden, where you become dependent on easy fixes instead of addressing the root cause. Recognizing these archetypes is a powerful diagnostic tool.
So CLDs show the loops, stock and flow tracks quantities, archetypes, spot common traps. What else?
Beyond those, you get into simulation models. These allow you to really experiment dynamically. You build the model, often using stock and flow, and then you run scenarios. Imagine a retailer simulating the impact of launching same-day delivery. They can test different assumptions about customer response, logistics costs, competitor reactions, all before making huge real-world investments. It supports that what-if thinking and helps identify risks and potential tipping points. And at the cutting edge, you have digital twins. These are real-time virtual replicas of a physical system, like a smart factory floor or even a whole supply network. The twin is continuously updated with data from the real system, allowing for incredibly precise monitoring, prediction, and optimization. It blurs the line between simulation and reality.
What strikes me here is the journey we all take, maybe unconsciously, from our everyday mental models to these more formal, dynamic simulations. We all carry around these internal blueprints of how we think the world works, right? But they're often flawed. We tend to think linearly in a world that's mostly nonlinear. We apply static assumptions to systems that are constantly changing. Our own cognitive biases, confirmation bias, availability heuristic, they create huge blind spots. Plus, our logic often gets fragmented across different departments in an organization, leading to misaligned goals. And, maybe the biggest one, we consistently underestimate time delays. We expect quick results from long-term efforts like changing culture or investing in R&D. We miss the long game.
That's perfectly put, and that's exactly why translating those often fuzzy, implicit mental models into explicit, formal system models is so incredibly powerful. When you make the model visible, tangible, you can suddenly visualize it, critique it rigorously, test its assumptions, simulate its behavior under different conditions, and continuously update it with new data. It transforms hidden, potentially flawed assumptions into clear, shared strategic assets. And the power of simulation, especially, cannot be overstated. It lets us test, refine, and evolve our strategies in a safe virtual space before the real world forces us to adapt, often painfully. Think about Singapore again. During the COVID-19 pandemic, they famously used dynamic simulation models to test various lockdown intensities, border controls, vaccination rollout speeds. This scenario-based modeling allowed them to navigate that incredibly complex trade-off between public health and economic stability with remarkable foresight.
And to achieve this level of sophistication, strategists today have this growing toolkit of STEM tools at their disposal. You mentioned system dynamics for feedback loops, agent-based modeling for individual behaviors, Bayesian modeling for updating beliefs, Monte Carlo simulation for handling uncertainty, optimization algorithms for finding efficient solutions, and those digital twins for real-time replicas.
That's right. It's an impressive array.
It's no wonder Singapore is often held up as an example, a nation that seems to model almost everything. Urban planning, pandemic response, education system evolution, energy transitions. They truly treat strategy not as a static plan to be executed, but as the adaptive modeling of a living, evolving system.
Which brings us to a really critical point. As strategic modeling becomes more powerful, more accessible thanks to these STEM tools, a significant layer of responsibility emerges. Because strategic modeling isn't just a technical exercise, it's profoundly a social and ethical act. These models, they reflect our assumptions, our values, and they directly influence real lives and real systems. So they absolutely must be designed with care and governed with rigor.
That's a vital point, and maybe one that doesn't get enough attention. So what are some of the biggest ethical sort of landmines that strategists need to watch out for when they start building and using these powerful models?
Well, one of the first and perhaps most insidious is the ethics of assumptions. Every model is built on assumptions about how the world works, and those assumptions reflect the modeler's worldview, often implicitly. Take predictive policing models, for example. If they're trained on historical arrest data that already reflects existing societal biases, guess what? The model learns and then amplifies that bias in its predictions. It's not a neutral reflection of reality. It becomes an engine for perpetuating inequity if you're not careful.
So the assumptions themselves carry ethical weight.
Immense weight. Then there's transparency and explainability. These models, especially complex AI-driven ones, shouldn't be black boxes where inputs go in and decisions come out mysteriously. There needs to be visibility into how they work, or at least how they arrive at their conclusions. And explainability isn't just a technical feature, it's a core leadership responsibility to ensure people affected by the model's outputs can understand, question, and potentially challenge them.
And involving people seems key too.
Absolutely. Which leads to inclusion and participatory design. Whenever feasible, co-designing models with the communities or stakeholders who will be affected is crucial. There was a great example in Nairobi where involving residents of informal settlements in modeling flood resilience uncovered critical local drainage patterns and community coping mechanisms that purely top-down, expert-driven models had completely missed. Inclusion doesn't just add legitimacy, it often makes the model significantly more accurate and effective.
Makes sense. What about the data that fuels these models?
That's another huge area, data ethics and privacy. Models, especially sophisticated ones, consume vast amounts of data. We need robust processes for informed consent, secure storage, clear anonymization where appropriate, and absolute clarity on how that data will be used. If a smart city initiative, for instance, tracks citizen movement data to optimize traffic flow but isn't transparent about secondary uses or data security, public trust evaporates instantly. Data ethics isn't just compliance, it's becoming a reputational and strategic asset.
Okay, assumptions, transparency, inclusion, data, anything else?
Yes. Finally, there's model lifecycle responsibility. Models aren't static artifacts you build once and deploy forever. The world changes, data drifts, assumptions become outdated. So you need processes for regular audits, continuous monitoring for performance degradation or emerging bias, and clear accountability for who owns the model and is responsible for its upkeep and ethical performance. An outdated workforce optimization model, for example, could start making discriminatory recommendations if it's not regularly reviewed and updated to reflect current demographics and legal standards.
It's a continuous responsibility, not a one-off task.
Exactly. And to uphold all these ethical considerations, governance and transparency really are the essential pillars. They ensure models build trust and legitimacy rather than suspicion and backlash. Why does governance matter so much? Because these models are becoming powerful decision engines embedded deep within organizations and society. They have real impact. Lack of proper governance doesn't just risk ethical failures. It invites public backlash, regulatory scrutiny, even litigation. Effective governance mechanisms include things like thorough documentation, strict version control, auditable trails of changes and decisions, independent oversight committees, maybe like a financial institution's risk and ethics board, reviewing its credit scoring models quarterly, and clear channels for redress if people believe a model has treated them unfairly.
And transparency is part of that.
Transparency is the outward-facing part of good governance. Strategically, being transparent about how models are used, their limitations, and the safeguards in place actually builds trust with customers, employees, and regulators. It reduces resistance to change, and it can even help attract talent who want to work for ethically responsible organizations. This is why we're seeing global trends solidify around this, things like the EU AI Act, the OECD AI principles, the US Executive Order on AI. They're all pushing towards mandatory safety testing, risk assessments, and independent audits for high-impact models. Governance is becoming table stakes.
It's clear this moves way beyond just the technical aspects. It's deeply human, deeply societal. What I also find really compelling is how strategic modeling isn't happening in isolation. It seems to be hugely enriched by borrowing ideas and lessons from other disciplines.
Oh, absolutely. It's fundamentally a cross-disciplinary endeavor, or at least it should be. Think about what we can learn from engineering. Concepts like modularity, building models, and adaptable components rather than monolithic beasts and fault tolerance, designing them to degrade gracefully rather than fail catastrophically. Don't build brittle one-shot models. Or look from biology, the deep understanding of feedback loops, adaptation, emergence. Thinking about an entrepreneurial ecosystem, for instance, it's much more like a rainforest, diverse, interconnected, organically adapting emergent properties than like a rigidly designed machine. Biological metaphors can offer powerful insights into complex adaptive systems.
That's a great analogy. What about other fields?
Well, from public policy, we learn crucial lessons about handling stakeholder complexity and assessing political feasibility. Policy models are often designed explicitly to explore trade-offs between competing interests and to test the viability of interventions in a messy political reality, not just their theoretical efficiency. They also bring sophisticated scenario planning techniques. From architecture and urban design, we can borrow principles of spatial thinking and human-centered design. How can we make models not just analytically sound, but also visually intuitive, maybe even emotionally resonant, so that diverse groups of people can actually engage with them, understand them, and contribute to them? Design matters for communication.
In computer science.
And absolutely, from computer science, particularly software development, we take cues on things like algorithmic transparency and the value of agile modeling. Instead of trying to build the perfect massive model up front, maybe deploy a minimum viable model early, get feedback, learn from its interaction with the real world, and iterate rapidly. Build, measure, learn. This cross-pollination is incredibly powerful. It enhances core strategic modeling with richer perspectives, smarter assumptions derived from different ways of knowing, and ultimately deeper human insight. The strategists of the future won't be siloed specialists. They'll need to be systemic thinkers who are fluent in many of these disciplinary languages.
So to wrap this incredible deep dive up, in a world increasingly driven by STEM, by complexity, by interconnectedness, strategy is no longer that static roadmap you just follow blindly. It is undeniably a dynamic system. And making that shift means moving from thinking in simple linear steps to truly thinking in interconnected loops. It means anticipating those often surprising ripple effects and consciously designing feedback-rich responses that allow our organizations to adapt and learn as the world inevitably changes around us.
Exactly. And what we've explored today really underscores that the strategist of the future must, I believe, be a systems modeler. Someone who is comfortable and adept with the powerful STEM tools we've discussed, yes, but also someone deeply, profoundly aware of the ethical responsibilities and the governance imperatives that come with shaping systems that influence businesses, societies, and individual lives. It's a role with both immense power and immense responsibility.
So, a final thought for you, our listeners. As you think about your own organization, your industry, your field, how could you begin to map out its current strategy? Not as a list of initiatives, but as a system. What hidden interdependencies, what feedback loops, what potential leverage points might you discover if you started looking at it that way? It might just shift your entire perspective on how your organization truly operates and where its future lies.